Hi, I'm Miriam Brenner, and this is Combining Like Terms. We have an expression, 5 plus 2n plus 3n plus 1. I want to find all the terms that are alike so I can combine them, add them, or subtract them together so I can get a single term. Alright, I have a 5 and I have a 1. Those are both just number terms, they're both constants. And then I have a 2n. This is a positive 2n. Because it has a plus sign out front that tells me it's positive. And I also have a positive 3n. So when I go to combine these terms, I have 2n plus 3n. And so if I've got 2 plus 3, that's 5. So altogether I have 5n. I'm not sure what n is, but I've got 5 of them. And it's positive. If I write it first, I don't need the plus sign out front because it's understood that something is positive if I don't have a plus sign. And now I have 5 and 1, and 5 and 1 makes 6. So I have 5n plus 6. And because I'm going to write it as an expression, I want to put a plus sign in front of the 6. If I had written it the other way, I could write 6 plus 5n. These are equivalent expressions. They're both expressing this same expression. They're equivalent to this one up here, only I've combined like terms to get these expressions. The one that has the variable first is the preferred way of writing it. We like to write variable term and then a constant term. So this would be the preferred form of an answer, although this is equivalent, and they're both equivalent to this one. They've just combined the like terms. Here's another example. We have an expression. It says 3m plus m squared plus 6 plus m. Again, I want to find the terms I have that are like, the ones that are just like each other. I have an m right here. This is a variable term with m as the variable. This is also a variable term, but it's a m squared term, so that's different than an m term. I have a 6. That's different than either of these terms. Then I have another m term. So that is like this term. I have a positive 3m and a positive 1m. Now I don't see a 1 in front of this m, but it's understood to be there. If I don't have a coefficient shown, it's understood that there's a 1 in front. This is just 1m. So if I combine 3m and 1m, I have a total of 4m. And then I can just bring down my other terms from the expression. I didn't have anything to add to them or to combine them with, but they're still there in my expression. So I'm going to bring them down. I'm putting m squared plus 4m plus 6. Now I could have written 4m plus m squared plus 6. Those would be the same. The commutative property of addition says we can rearrange the order. I chose to write it this way because we like to put variables in order, and we put them in order of their power. This one is m squared. It gets to come before the ones that are just m, so I put it first. But it would be acceptable to have 4m plus m squared plus 6, or 6 plus m squared plus 4m. Those would all be equivalent, and they would all be showing that I've combined the like terms of 3m and m. Just one more example. This expression says 6p plus r minus 4p plus 3. I'm looking for the terms that are like each other. This is a p term. This r term, I don't see another r term, but I do have another p term. This is a minus 4p term. And so when I combine these, I've got a positive 6, and I'm subtracting 4. So 6 minus 4 is 2. This is 2p. And then I still have an r term and a 3 term. So I'm going to just write those r plus 3. And so I can rewrite this expression as the expression 2p plus r plus 3 by combining the p terms. You can also think of that as the distributive property. I can pull out that p out of both of them, and then just have p times 6 minus 4, and 6 minus 4 is 2, and 2 times p is 2p. So we can think about it two different ways, either just subtracting 6, if I've got 6 pretzels and I subtract 4 pretzels, I have 2 pretzels. So this combined term is 2p. Also, just a note about the order. We put variables, if you've got more than one kind of variable in expression, we put them in alphabetical order. So p is going to come before r. If you would like more help on combining like terms, visit our classroom wiki at mbrunnermath.wikispaces.com/home.